So we have magnesium reacting with oxygen to give us what? Correct, magnesium oxide. Is this balanced? It's not. So let's do it. It's a practice, right? Let's not lose an opportunity to lose, right? Now, first we wrote all the reactants and the product on the first row, and in the first column I wrote all the atoms involved in the reaction. I'm going to count them. In Mg there is only one Mg, no oxygen. In O2 there is no magnesium, but there is 2 oxygen. In MgO there is 1 magnesium and 1 oxygen. So this has to be 2, only then O2, oxygen will be balanced on the LHS and RHS. For to get 2 oxygen atoms, the Mg has to be 2, right? Only then you will get in this column 2 oxygen atoms. That's the whole funda, is it not? If MgO is 2, even the magnesium will be 2. For the magnesium to be 2 on the left hand side, this has to be multiplied with 2, and so this is 2. And so basically what we are looking at is 2 Mg, which is a solid, plus O2, which is a gas. This can happen at room temperature, but if we want to see MgO, a rapid thing, to make things move faster, we make use of heat. Okay guys, this is the funda. So obviously the main change over here is changing color. So what are the changes? We have one is change in solid appearance. This is what I'll start with. So this is a shiny silvery gray. This too you'll get to see that the experiment, it burns nice actually. Reacts to form, so it reacts with oxygen to form white powdered solid, which is nothing but your MgO. This is one of the indicators. The other big indicator is there is a bright white light and heat. So basically this is an exothermic reaction. Actually I didn't make it clear in the reaction. Plus light and heat. So basically we're looking at an exothermic reaction. It produces a bright white light, I've written that, and significant amount of heat. Okay, I think these are the two big indicators. Now, why does it happen? Let's look at it. Where is Mg? Mg is over here. Oxygen is over here. So these are at the two extremes. It will be a strong ionic bond, right? So they'll be very stable. It moved from unstable to being very stable. So what happens? Energy has to be released, and so we are getting this white bright light and all of that. Can you see that? Can you map all of this? If you have seen the basic video, this should make sense to you immediately. These are at the extremes of the table, periodic table. Right guys, and you can look at the valency, that's why it's MgO. Look at the electronegative value, look at the electron affinity. So you can see all of this, right? And you should be able to guess it, why the reaction is so violent. So I'm not going to the details of why is it violent. Again, to understand all of this in a very nice manner, please watch the basics. Chemistry basics, we have worked hard on that and we are going to add a lot more. We'll keep adding, right? It's on you to learn it. Okay, so since we're looking at redox as the main heading, so let's look at what is getting oxidized over here. And yes, of course, it's quite simple. So we have before and after of what is that we're looking at? We're looking at Mg and MgO. So this strip of materials oxidation state is 0, and here it will be Ng plus 2. So it moved from 0 to plus 2, implies it lost electron, right? You can see that it has to. This guy will pull it out. Oxygen will pull it out from magnesium. That's what this table is telling. Since it will pull it out, and so this says thus it's oxidized. Your Mg gets oxidized. Agree? Again, when you see this experiment, you'll understand that why the bright light and relate it to periodic table. Go back to periodic table. It helps a lot.